Thanks, Maureen. I suppose really today's presentation was all about the non-complex buildings. And really the technical guidance documents, really A to M, cover non-complex buildings, apart from the volume B for buildings other than dwellings and part L. So every new house that's got planning permission needs a commencement notice. And you're required to submit general arrangement drawings, plans, sections and elevations, a Part L compliance report or calculations of specifications, and at least one of the following: a preliminary inspection plan prepared by the signed certifier if it's done under SI9, and a compliance report with the second schedule of the building regulations 8M. We really never really get to see a full compliance report from 8M, and it's something that designers need to start developing and have that in the thing. So if you go on to the requirements in SI9 of 2014, so form of commencement notice, Article 9.1, commencement notice shall be filed electronically on the BCMS as the preferred means of using the BCMS. And such plans, calculations, specifications and particulars are necessary to outline how the proposed works or building will comply with the requirement of the second schedule of the building regulations, which is the building regulations 8M, and relevant to the works or building concerned, and include general arrangement drawings, including plans, sections and elevations, a schedule of such plans, calculations, specifications and particulars as are currently designed or are to be prepared at a later date. So your Part L really should be submitted at design stage. Your ACDs, whether you're using them at that stage, or should be part of your general arrangement drawings. Because your foundation details feed into your thermal modeling and they're part of the thermal model. So the Building Control Act 1990-2014, the Act provides for the health, safety and welfare of people in about buildings, access for all, the conservation of fuel and energy, and the promotion of good building practice. So the welfare part of this is the thermal comfort, the mold growth that you don't want in buildings in Part L. So new dwellings, the requirement of L6 in 2021 is the use of renewable energies sources, limiting heat loss, air infiltration, thermal bridging, air pressure testing, space heat and water supply system controls, energy, artificial lighting systems and water conservation measures are all part of the requirements of L6. And we're only dealing with thermal bridging today. And that's one element of the requirements in Part L. So what is a thermal bridge? So a thermal bridge is one of the most significant sources of heat loss within a building. A conductive material or a gap in the insulation can form a bridge between the inside of your home or the outside, where heat can escape heat flow the path of least resistance. So a thermal bridge can be caused by the junction between the wall and the floor, the junction between the wall and the roof, holes in the building envelope for pipes and cables, windows, doors, reveals, steel wall ties in masonry construction, e.g. cavity walls. So you can see the detail here on locations of typical thermal bridges in the technical guidance document. So there's two types of thermal bridging. One is the fabric insulation and thermal bridging Y value. So that's a repeating thermal bridging, and that's accounted for in your Y value calculations, and that's the wall ties in your masonry or your joists in your ceilings, or a linear thermal bridgings, and they're not accounted for in your U value calculations and must be evaluated separately, or you use the ACDs. So procedure for accounting for non-linear thermal bridging. So first thing there, a designer needs to do, and these are the designer's roles. A designer needs to prepare a schedule of all the key junctions in the building and draw them. And then he needs to check that each key junction is assessed in a conformance with the ACDs. So he needs to know what he's going to have his U values for each element. And he needs to match that with the details in the ACDs and see that he doesn't exceed the 20% difference in it, because you're never going, the ACDs account for 0.15 and 0.15 on the U value, and with the materials and stuff like that, you're never going to actually get 0.15 of the U value. So that's why there is that tolerance of the 20% there, plus or minus. So the acceptable construction details, so the guidance is all in there, the part 1 and part 2 that was in Simon's presentation. And the general notes on how to use them. Very important that you read the fine print and the asterisks and all of that, because that's where the information, when you need to assess your conformity, that you can use the ACDs, you're using the notes here. Also, just some of the ACDs highlight an R value. And the R value is calculated by the thermal resistance of the product and the insulation conductivity, and that'll give you the thickness of that material in millimeters there. And also remember that you have all the checklists on it. So the documents are very good general arrangement drawings if you put them on a paper and put your additional specifications for your blockwork, your masonry, your renders, your concrete, your cavity barriers, all of that can be specified on it, and you have a full set of general arrangement drawings. And your ACDs all in the one. Also there, it's good practice there to write your U values, backstop U values that you're using on your drawing there, so that you can show that you have achieved your 20%. Maybe a note that could be done and if they're revised again. So options for a Y value. So if the key junctions detailed are not in conformance with the relevant ACDs 2021 or 2011, you must use the default value of 0.15 or alternative use option 3 below, but you must calculate your mold growth and surface condensation risk in accordance with paragraph D2 of Appendix D in Part L. So if the key junction details are in conformance with the relevant ACDs, you can use the Y value of 0.08, or you can get a better Y value by creating your table and calculating it. If some or all of the key junction details are not in conformance with the relevant ACDs, you have to calculate the Y value. So if you're getting something thermal modeled, you're into calculating your Y value. And the thermal modeler has to be on the NSSI approved scheme, and they will carry out the FRSI calculation as well as part of that modeling. So why should you use the ACDs? Well, if you go to the Part L technical guidance document or any technical guidance document, you'll see this note in the introductions. Where work are carried out in accordance with the guidance in this document, this will prima facie indicate compliance with Part L of the second schedule of the building regulations. However, the adoption of an approach other than that outlined in the guidance is not precluded, provided that the relevant requirements of the regulations are complied with. Those involved in the design and construction of buildings may be required by the relevant building control authority to provide such evidence as is necessary to establish that the requirement of the regulations have been complied with. So the ACDs are free, they're done for you, and they indicate prima facie compliance. If you're using your 0.15 or calculate, you need to demonstrate to the building control in your design how you've achieved your thermal bridging design and your Y value. So authorised officers, so all building control officers are authorised under Section 11 of the Building Control Act, and they can require the owner or occupier of a building or any person responsible for the construction of the building to provide such plans, documents, and information as are necessary to establish whether the requirements of the building regulations are being complied with in relation to that building. So if you get a Section 11 request and you fail to respond to it, it is an automatic enforcement. And you go up in front of a judge and the building control officer says, we requested that person to send in information on their section, and the judge would say, did they send it in? Yes or no? And the building control officer will say no, judge will say, get that in. I'm giving you a couple of weeks. It's not reason, and he's not really concerned about what the request was. So this will be a typical Section 11 for Part L6 compliance. And I just highlighted there limited heat loss and air infiltration on the thermal bridging. And they're what we'd expect to do. So your minimal acceptable U values. So that's really a calculation of your U values, how you've met your backstops and for your windows and all that. And you might have to use certified calculations for that. And then the thermal bridging and the limiting of air infiltration, that can be as simple as an air test, and your ACDs show compliance with both air infiltration and thermal bridging. So what we want to see as a response to a Section 11.3 to the building control is drawings showing your Part L compliance report in deep. The Y value is included in, you can see there the thermal bridging factor here, as they've used 0.08, and drawings showing the locations of your key details. And then if you're using the Y value of 0.08 or less, submit copies of the ACDs or a thermal model. So you want to make sure that you have a thermal modeler and that it's approved there by a thermal modeler. Andrew's there. And it's the software, and you can see the calculations given there. And you just put in the ACDs that you're using that's relevant to your project. You don't need to put in the whole lot, and you should draw them out. And if you calculate it, you can use the SESI thermal bridging calculation software tool or an Excel sheet, simple. And response there, if you're using a Y value of 0.15, so you have to carry out the thermal bridging at the junction around the openings, the Appendix D risk. So your FRSI calculation, so you can see it down here, it's 0.096, which is fairly high, but, you know, but it exceeds the 0.75. And that does not require to be done by a thermal modeler. Anyone who's trained in the software and is comfortable doing it and competent to do it can do that. But that is the only way that you can check that you have complied with Appendix D, is to carry out analysis by computer analysis to verify that there is no condensation risk. So I'll just summarize that into a little table there. So if you're using the default 0.15, you still need the Part L report. You need the key junctions. You need the details of the ACDs. You need your FRSI calculations, but you don't need a table of calculations because you're not calculating your Y value. 0.08, yes, yes, yes. FRSI calculation, you don't need them because they are part of the ACDs. They're already calculated for you. And if you're not calculating it, you don't need to provide the table. If you are, you do. And if it's less than 0.08, yeah, and the note here on the ACDs, you may have to get, only if not approved ACD, that you may have to use a thermal model thing. So just basically, that's the type of information that you should be providing to show compliance with Part L in relation to thermal bridging. So the code of practice for inspecting and certifying buildings, it defines the competent person. The person is deemed to be competent person where, having regard to the task he or she is required to perform and taking into account the size and or complexity of the building or works, the person possesses sufficient training, experience and knowledge appropriate to the nature of the works to be undertaken. So you can all agree there that what Andrew showed us and his knowledge of thermal bridging, he would be deemed a competent person. Same with Simon and Gary and Dara. And most of us in the office here would have certain skills in competencies. You mightn't have them all in part A to M, but we all have skills in this. The designer has the role in it too, the Building Control Act as well. And the preparation of plans, particulars, drawings, specifications, calculations, and other expressions for the purpose of the construction, extension, alteration, repair, or renewal concerned in the execution of the design to be constructed accordingly. So the designer here has to put all this information together, has to be talking to the thermal modeler, has to be making sure that his key junctions are in compliance with the ACDs if he's using the ACDs. And if he's not using the ACDs, has to get his FRI calculation and use the default. So your inspection notification framework and that, and your inspection plan, and your ACDs need to be built into this. You need to be out inspecting that the builder is doing the ACD as per your design and putting in the key things. And he may have to provide picture evidence and record things, and that can be all part of your notification framework. The assessment and inspection selection for projects should be based on, this is part of building control, a risk management based approach, a level of random assessments and inspections. So building control may say, you guys using the Y value of 0.15. Let's go out there and check to see what details the building and have they assessed it for FRI calculations. And that's a high risk. Because if there's no drawings part of their submission, general drawings that detail how to comply with the ACDs, then how are they complying with the condensation risk? So annual inspection reports should be available to the assigned certifiers on completion, and this is part of the code of practice. And just to remind all local authorities that they have to inspect 12 to 15% of new buildings valid commencement notice received in the year. And the selection of for inspection based on plans and documentation. So the primary inspection, preliminary inspection plan prepared by the ACDs may only include 1 or 2 inspections. So that's a risk for non-complex buildings or housing developments that they need to go and re-evaluate that and check the plan, the preliminary inspection plan to see what inspections are laid out and what levels that provided. And then the drawings on particular details. And if a building control officer carries out a desktop assessment and finds that there are omissions or that insufficient design information has been provided, a Section 11 request should be issued by the Building Control Authority. So we move on to Part D, and this is equally important as Part L. The materials that you're using in your construction, your insulation and all that, and the properties of that all feed into thermal modeling as well. And they have to be fit for purpose. And it defines the meaning proper material for use and work in assessing its fitness for the conditions of use and material product considered should be given to durability, safety, local climate conditions, so e.g. wind-driven rain, humidity, etc. and that. So it is a document that's probably overlooked by a lot of people, but it is key to all the building regulations because materials is used in all parts of construction, and compliance with A to M involves the materials in most building regulations. So all works to these regulations shall apply and carry out with proper materials and in a work-like manner. So it is equally as key that the person that's using the material is trained to install it. And in the insulation and that and retrofitting, that's why the NSSI have schemes for like that for improved installers. And the argument certs, as you'll find, that there's training involved in that too. That the people that are competent to erect these modern methods of construction are included as well. So certification, but these were products that don't fall in under the European construction product regulations or stuff like that. And an independent certification scheme has to be sought for these products. So they need to be assessed by a third party to say that they're suitable. And that's the likes of the ICFs. And it's just a key detail in here. You know, it's a small wee note and it's just a fire cavity and it's shown put in place. But it's important to have these details and these notes and understand them as well. And that's why competent people that are trained in this are highlighting them details, and designers need to be reading the notes as well, because they may have implement cases for other things. And the other thing too is these junctions need to be thermal modeled, you know? So the concrete floor one versus the timber could be totally different because you're breaking the insulation here. That's a straight wall, technically. But here, the concrete is actually cast in on part of the system. And it probably has a worse psi value, has it? The other thing too, bead insulation, you can actually search for argument certs on the thing there. And just, this is our exposed map in the country, and this will probably be changed in the next couple of years. But anywhere in that green area is considered severely exposed. And your materials that you're using in that have to be fit for that climate. And you'll see that some of the assessments there, the assessment of the exposure zone and the risks and all that, and a complete survey report may be required. And these are all listed in the argument cert, but it's up to designers to make sure that they're getting that because they're supervising this work. And the assigned certifier needs to coordinate the design of all the others and make sure that the certificates for this design is gathered up. This is a question we nearly get all the time. I have a BBA cert. Can I build it? So if you go to the technical guidance document D, and in 0.10, we're getting a lot of decimal places today. But the process of argument cert, so they're basically saying that they have to be in accordance with Irish building regulations. Full stop. Most BBAs are only assessed for UK regulations, not equivalent, because we have slightly different in all regulations. So the designers should be going back to the manufacturers and saying, we cannot use your product because it does not comply with Irish building regulations. And if everyone did that, they would be rapping on Gary's door and saying, we need a cert quick. Can you look at this? We're not able to use this product. And this is happening out there. And designers are taking a big risk because they're breaching the building control and they have to go in and able to demonstrate compliance with Part F and a building that's built, or Part D, in a building that's already built. And they may have to do reports and everything, and they still may have to go to NSSI to show that it complied. So the testing and performance. So all products are tested to some performance, whether it's this, the lambda value and all of them are calculated and stuff like that. And some of them are tested for fire performance as well. And then there's performance and use details. So this detail in the technical guidance documents, so the separation of walls, there's a performance and thing. There's no real test for this, a standard test, but it works, and we all know it works because we can see it there in the house. It didn't do much damage to the next door house. Right, common overview of common problems. So poorly positioned cavity insulation. So the cavity wall insulation should be installed tight to the outer face of the inner blockwork leaf. This will prevent air circulation between the block and the insulation, reducing the performance of the insulation layer. There's no point in buying expensive insulation and leaving big gaps like this, and you're not getting the full value of the insulation, right? And you can see it here, like, and just poorly detailed. I think a picture would get a hand in one of them. Debris and creating bridges in your blockwork, and then maybe overusing of your wall ties as well that you may not have accounted for. Your locations of cavity barriers and dirty things, and you can see it here as well. Mortar drop down here. And who's going to close off this little bit? Do you know? I like this one here. This is a thermal bridge. Right? There is none of this in the ACDs. And if you see this on site, it doesn't belong on sites if someone has mentioned they're using ACDs. And you can see here the gaps of insulation, you know, what they're doing, throwing it in. This is the cavity closer, and look, the gap. Also too, this detail now that has come in, and the insulation needs to extend down into the cavity closer. The guy that's doing the attic insulation, he's the last man. He probably doesn't know what he's doing, but who's checking to see that he's filling in that thing to make sure that's scraping down there? You know? Surface penetrations too. I've seen this one here, they were using a kind of a box here for a fire hydrant. It was very good. Insulation seems to cut out well, and it means they can come back in there and foam that out, and it's nice and tidy. So keep the holes and penetrations. And the other thing here is with the blown in insulation that's becoming very popular is your DPCs here. You know, ensure that there's a bit of rigid insulation there, so you're not drilling through concrete heads or structural elements, and you're performing that sloped insulation there so it drains the cavity right. And you can model them junctions as well. And you're looking for the assessment on that report as well for that area. And there is a requirement in there that you cannot have more than 2 service areas on these aggregate sites. So they may create a fire hazard. So, and the other thing too is you're going to have a cold bridge in here unless you provided rigid insulation in here behind the back of your box. Timber frame. Just to note to all the timber frame manufacturers out there that they do require this all value now. So they need a bit of insulation or an insulated slab around the jambs and reveals of a window. So anyone, the timber frame manufacturer might come in, and the slabbers and the designers need to check that that's been done. It's part of the detail. And that's really was added there to help meet the oversight calculation, not to improve the psi value. So it was a condensation risk that was assessed that needed to be there to reduce that condensation risk. Provision of cavity barriers. So these are examples where missing completely. We'll say half put in right and half put in wrong, but still wrong. And blown in cavity, So you're putting a bead that can actually, if this was down in Cork or Kerry or Donegal, that the moisture can get in here, that insulation is not going to fire, it's going to get wet and it's not going to be effective. And it will soak up. The big issue with this in the UK, where mineral wool was pumped into cavities and a hole had to be taken out in exposed areas, and it's costing a fortune. So the cavity barrier detail is there in the technical guidance documents, and the locations there in 3.6 of Part B 2017. So why to use the ACDs? So heat junctions are designed for you. No need for assessing for mold growth or surface condensation. It reduces fabric loss in the building. It provides additional guidance on Part B, E, and air tightness, mainly. They can be further developed to be general arrangement drawings with additional specifications on materials to be used. The reduced amount of renewable energy sources required for Part L compliance, and the save on heat cost for the lifetime of the building. Especially when we have an energy crisis probably coming in the next winter, that you're designing a house that's actually going to save you money over the lifetime of the house. Just go on there on the requirements of the BER assessor and register of BER assessors and your Part L report. And SI 243 requires that you need to have a BER before you can occupy a building. So just your BER, the checks for the page 5 is there's a Part L conformance check. So it tells you whether you pass or fail. And you may fail one of the backstops here, but you pass overall because maybe you had a better Y value or you had compensated the values on it, and you meet it by the provisions in the clause 1323. So really what you want to check there is the address is correct, DPC, CPC, fabric, windows, doors. And you can look up the Y value, which is actually on page 4. It's not part of the Part L conformance checks. So each building control authority are delegated officers under SI 243 of 2012, and they can request this information from any building that requires a BER or that's advertised or rent. So a person who commissions the construction of a new dwelling, the construction of which commences on or after the 9th of January 2013, shall, before such dwelling is occupied for the first time, secure a BER certificate in the form prescribed and an advisory report. And that's a regulation that's required. And the enforcement authority for this is the building control authorities. And SI 9 is also enforced by the building control authorities. So when you get a CCC submit a CCC for a new building before it can be opened or occupied. So a building control officer will need to see the BER and the CCC at the same time to say that that building can be opened and occupied, because he has the function for both regulations. And he can't say one without the other, seeing the other. So that's something that we get signed certifiers asking, I don't need to provide a BER. You do, because it is compliance document required before you can open a building. And a CCC is required before you can open a building. So it's just the designers, when they're signing their undertakings and all that, I confirm that I have been commissioned by the builder or owner, building owner, to design in conjunction with others the buildings or work described above, and to certify such design I further confirm that I am the person named on the register pursuant to Part 3, Part 5 of the Building Control Act or Section 7 of the Institute of Civil Engineers Chartered Amendments Act 1969, and I am competent to carry out my design and to coordinate the design of others for the building or works concerned. I confirm that the plans, calculations, specifications, ancillary certs and particulars included in the schedule to the 7-day notice or notice to which a certificate is relevant and which have been prepared exercising reasonable skill, care and diligence by me and others, members of the design team and specialist designers whose design activities I have coordinated have been prepared to demonstrate compliance with the requirement of the second schedule of the building regulations insofar as they apply to the building or works concerned. So that's a big statement for a designer to do. So they're saying that everything is designed and done. FRSI calculations, my Y value and all that have been checked, and if I have to calculate my Y value, I've done that, and I'm building in accordance with the ACDs. So building control officers starting to get tough, you know, and it's to work with these people and designers and go out and meet them on site and highlight them, and if they're not aware of the ACDs, show them the ACDs, have little discussions with your designers in each local authorities and pull them in and introduce them to the new ones. Like they're 2021, they're on the department website. Everyone should be looking for updates and on the department and all the new technical guidance documents. So if you're not aware of your obligations under the Building Control Act, I'd advise you to stick to a professional to assist you with this. So if you don't know anything about building or designing or commencing a building, you need to get professional advice. So just a couple of things there, our NBCO channels there. Our last event there on the ventilation validation scheme has actually resulted in a lot more requests for building controls on Part F compliance. So it is actually working these ZP these days. We also have, in conjunction with Certificate of Building Control Management, and this is open to assigned certifiers, designers, ancillary designers as well. And it gives them a full knowledge of building control regulations, building regulations, the BCMS, and submitting of fire service certs and stuff like that. So, and that's actually closing end of September. So if the registration, the link to the application there will be there. It is actually on our Twitter page as well, and that you'll find it mostly there. And the recordings of all these presentations are going to be up on our NBCO channel to look back and reference. So, thanks.